High-intensity laser is a device which produces coherent light of one or more specific wavelengths. A laser beam carries energy which spreads through the tissue and can be used to treat inflamed, torn, or otherwise damaged or infected tissue, in which it speeds up healing, recovery, and reduces pain. High-intensity laser penetrates the skin non-invasively and spreads further into the subcutaneous fat, muscle, tendon, and bone tissue, depending on the location of the treated area. The process through which laser heals the damaged tissue is called photobiostimulation. Upon application of laser light on human tissue, there are 4 different effects that occur. Reflection, the light doesn't penetrate the tissue. Scattering, the light is distributed randomly in the tissue. Absorption, the light is absorbed by the molecules of the tissue. And transmission, the light is transferred deeper into the tissue structures, being absorbed eventually. There are 3 key effects of therapeutic high-intensity laser: photoacoustic, biostimulation, and thermic. Human tissue is composed of various components, of which the most important for laser irradiation are water, hemoglobin, and melanin. Their absorption, as well as the scatter coefficient, are different for different wavelengths. The optimum scatter to absorption ratio of 1064 nanometer wavelength makes it ideal for deep tissue penetration. A 1064 nanometer high-intensity laser beam can reach up to 10 centimeters deep into the tissue. One of the key effects induced by the 1064 nanometer high-intensity laser beam is the photoacoustic effect. Photoacoustic waves are created when the area is irradiated by using very short pulses with a high repetition rate. Such mechanical waves stimulate free nerve endings in the tissue and cause nearly instantaneous pain relief in the area. Biostimulation, in other words, stimulating the organism on the cellular level to enhance healing and recovery with a 1064 nanometer laser beam, is another key effect of the high-intensity laser. Oxygen is processed in cells by mitochondria. Here, oxygen is processed by a cascade of respiratory enzymes and delivered to ATP synthase, which synthesizes the organism's source of energy, ATP. A faster exchange of oxygen and metabolites due to laser irradiation causes more oxygen atoms to reach mitochondria. Mitochondria are further stimulated to synthesize ATP faster by laser irradiation at 1064 nanometers. ATP allows for faster synthesis of RNA and DNA and leads to faster recovery, healing, and edema reduction in the treated area. The thermic effect of high-intensity laser therapy is caused by absorption of the 1064 nanometer laser beam in the superficial structures, which consequently causes temperature increase in the tissue. The thermic effect also causes vasodilation. As a consequence, blood perfusion increases, larger amounts of oxygen are delivered to the tissue, and more metabolites are resorbed.